currently working as production data analyst at Affinity. I recently built a production level web scraper for one of my clients that collects influencers profile at a massive scale from a website, uh, FluencerDB. And the best part of the uh, script is even if the script crashes or stops for any reason, it picks up right from where it left off. In this video, I will walk you through the architecture, explain the key engineering decisions behind it, and then wrap up with a quick demo so you can see it in action. So this is the live output. You can see how it's organizing the ID, name, username, phone number, the following, and other information. It saves a separate file for each keyword. It removes the duplicates automatically. So this is the project structure. The scraper follows a modular design. We have built separate modules for navigation, parsing, uh, progress tracking, and Excel output. Uh, it's built with Python using Selenium, undetected Chrome driver to avoid bot detection, and we have used Pandas for processing the results. The system is engineered to handle real-world scraping scenarios. It can resume after crashes and consistently generate clean production quality dataset. Before we go to the demo part, here's a high-level breakdown of this project. The scraper is mainly built around five main components: the config, the driver, the navigator, the parser, and the utility modules. So the config file keeps all setting in one place. Things like base URL, maximum pages to visit, and output directory. Now the driver part. So the driver module is responsible for launching the browser. I'm using undetected Chrome driver, which helps reduce automation flags and keeps the session stable. So this module is responsible for setting up the Chrome options, initialize the browser, and make sure that we always have a clean web driver before scraping. Now, next part is the navigator. This part handles the actual movement through the website, running the keyword search, loading the results, and also managing the pagination. Uh, the smart bit here are important. I'm avoiding the fixed slaves and instead waiting for elements to load properly, which makes the scraper more reliable and faster. This function go to next page allows the scraper to move to the next page. The navigator returns the HTML for each page and then hands it off to the parser. Now the parser extracts the structured data from the HTML table, and for every row in the results table, it pulls out the clean fields like name, username, followers, following, etc., and returns them as Python dictionary. Keeping the parser separate makes it easy to adjust fields later without touching the navigation or driver code. Next, the utilities handles the rest of the workflow. The Excel writer saves each keyword to its own file and deduplicates the data using Pandas. So we always get a clean dataset. The progress tracker uses a file progress.json as checkpoint, which means that if the scraper crashes or the browser closes, it can resume exactly where it left off. The keyword utility is responsible for getting the keyword from the file and then remove that keyword from the file. Now, I want to discuss few key engineering decisions which make this setup more reliable for long runs. I saved the data every 10 pages so that the crash recovery is uh, fast and safe. And in the finding block, the driver always closes, so we never leave a zombie Chrome process running in the background. And all of this together makes this scrapper stable enough for real world and large scale of the data collection. So before we jump into the demo, let me quickly walk you through the how the scrapper actually works behind the scenes. The main.py file is the orchestrator. It connects all the components together, the driver, the navigator, the parser, and the utilities. So at the top, I import the configuration settings, the Selenium driver, the navigator functions for searching and pagination, the parser to extract rows, and then the utilities for saving the files and tracking progress. Now the scrapper starts by loading all the keywords from a simple text file. Each keyword represents one search run. This helper function removes the empty lines and cleans up spacing, so we always get a clean list of words to work with. Next, we load uh, the existing progress from progress.json file. This file is the key to crash recovery. Let's say if the script stops at page 47, so in the next run it will resume from page 40 automatically. Now inside the main loop, we loop through each keyword one by one, and before we start scraping, we remove the keyword from the file. That way, if the runs succeed, it won't repeat. But if something crashes midway, the keyword is retried in the next run. Now, each keyword is wrapped in a retry loop. If anything fails, like a timeout, a browser crash, or parsing error, uh, the script will just sleep for 5 seconds and try again with a fresh browser instance. This is one of the main reasons the scraper is stable for long runs. Now here we are launching the driver using undetected Chrome driver to basically reduce the automation flags and keep the session stable. And every keyword uses a fresh browser instance, which helps avoid memory leaks and random prompt phrases. Then uh, the navigator performs the initial search for the keyword and if we are resuming, it jumps directly to the last saved page, and from here the scraper enters a loop that processes page after page. Then the parser extracts uh, all influencer rows from the front page and converts them into the clean Python dictionary. Then we store everything in the all data, and this keeps going until the run is complete. Now, after every 10 pages, uh, the scraper saves a checkpoint. It writes the data to the Excel sheet and also updates progress.json. And we keep on moving to the next page until either we reach the maximum page limit or in the next page a button does not exist anymore, which means we have scrapped uh, all the data. Now, after the final page is scrapped, we do one final save to the Excel and update the progress. At this point, the keyword is considered complete. And now, in the finally part, no matter what happens, it's a success, failure, or any exception raised, the browser always get closed in the finally block. So this prevent zombie processes from piling up in the background. So that was the full flow of the project. A quick recap: it load keywords, resume from progress, scrap page by page, saves every 10 pages, and in the end, always clean up the browser. So this way, the scraper is stable, uh, it's recoverable, and safe for long running jobs. Now, let me show you how it performs in real time. All right, now let me show you a quick demo of the scraper in action. I'm going to run it for one keyword so you can see the flow, how it loads the browser, visits each page, extract the influencer records, and create checkpoints as it goes. Let's start. Now the scraper is starting up. It's launching the Chrome driver and performing the initial search for our keyword. We have to fill in the captcha. Let's verify it. Okay, so now this is page one. The parser is now extracting records from the table and adding them to the memory. Here we can see the logs. Now it's going to page 2. So here we can see it's now on page 2. Now moving to page 3. Since I have limited this demo to only 3 pages, so the scrapper will stop once it hits the page limit. Now the scrapper completed its job, and here that's the final save. All the extracted records for this keyword have been written to the Excel file, and the progress file is has been fully updated. So that's the complete process. In Excel, we have stable navigation, clean parsing, automatic checkpoints. Now let me show you the resulting output file. So yeah, here's the data that we get for this keyword. Thank you very much for watching this video. Now, if you want to get in touch with me, here's my LinkedIn profile. You can find the code for this and other projects on my GitHub. And here's my email, samafis.abasi1234@gmail.com. So if anyone wants to collaborate or if anyone needs any sort of suggestion or anything, you can contact me on this email.